Well, I would like to thank you very much for the opportunity to be here. The other uh, side of the word for me. So I'm going to talk a little bit of what we have been done in Brazil. And I come from the university, but I worked for the Environmental Protection Agency of São Paulo for many years. So when I quit, I decided to try to link academia with real action. So I'm going to show what I have been done so far. Okay, immersion pollutants, it's very nice because she said a lot about it, so it's easy to go forward. But I think there is something that you need to know. I think it's because of the chemists that we have the immersion contaminants. Because this is not new. We have been drinking all that stuff for years and years. But this is just because the chemists now, they are able to analyze it. And they are always ahead of us, biologists. And then now we are able to detect nanograms, picograms, and I have a friend that said to me that if there is only a molecule in in a glass of water, it's possible to analyze. So it's going to become very, very difficult to manage all that information. Well, I'm going to jump ahead a little bit. I had a project in endocrine disruptors, and I'm going to show a little bit later. But now we decided to move forward to pesticides. And pesticides are also can be considered immersion contaminants, some of them, and endocrine disruptors. And Brazil is #1 in the use of pesticides. It's amazing. We have a lot of pesticides in place. It's 380 pesticides. And I'm going to show what we have in monitoring right now. Okay, this is when we started, we decided to see what we have in terms of papers and information on pesticides in Brazil. And it was amazing. We almost don't have any information. Just in 4 states we found information. Only they look at 43 pesticides among the 380 that are in place in Brazil, and they found 34. Those are the ones that there is in the literature, and you can see there is a variation, a big range of concentration, and we only regulate the ones that they are here in those in this black stars here. So it's very hard to interpret the data, and also what amazed me, it was we don't know what's going on in Brazil in terms of the country. Because everybody, they always have those basic monitoring, which is fine, but we need to know about it. So we decided to move a little bit ahead, and we published this paper recently where we validated, where we implemented a method to analyze pesticides in water in nanograms per liter. We want to know if pesticides were there. This is what we found. This is just the beginning of our work. From the 19 pesticides we analyzed, we found 15. Those are the pesticides we analyzed for, and those are different rivers. So you can see they are all there. They are in nanograms per liter, but they are in almost all the rivers we analyzed. This is just a preliminary data that we have. Well, we also went to the drinking water just to take a look, and we found almost a lot of them in the drinking water as well. And atrazine is everywhere we look for, and I want to point out this blue line here. This is groundwater, very deep, and this is drinking water and comes from groundwater. So atrazine probably is going to be in all the wells in Brazil because of the huge use of herbicides. So, well, then with that numbers, we need to interpret that, right? We know they are there. So this is what we have a group in Brazil. We are trying to calculate water quality criteria for the different uses of water. And this is hard because everybody goes to the WHO guidelines and they say, well, I don't find it for the carbendazine or whatever, I don't know. And then it's very hard, we don't know what to do. So this is what I like the most to do. So I studied a lot and learned a lot during all those years. And now we came up with a book that I'm going to give to UNESCO library that we brought. This is a book trying to explain to people that you can calculate your own criteria if you have data. And for pesticides, we have all the data. The industry provides that data. So in this book, we are showing how to calculate, we are talking about other issues, and also chemical analysis and so far. So it's available at the internet as well, but unfortunately it's in Portuguese. But we have a document that is was previously published, the same one that I'm showing here. We did a meeting in Brazil. I invited several people from all around the world, and I said, well, imagine that you are in heaven and you can do, what do you recommend for us to how we should do this derivation or protocol for derivation of water criteria. And we came up with this criteria for aquatic life protection. This is published, also available in English and in Portuguese at this webpage. And we have also the same document for drinking water, so you are welcome to take a look. I think it's very interesting to see it's not so difficult to come up with the criteria. So our conclusions, we conclude that data on pesticides in the water in Brazil are very scarce. I didn't show about drinking water, but this is really bad. We almost don't have any information. Although it's in the law, but it's not good, the information. Several non-regulated pesticides, including the ones suspected to have endocrine disruptors, were found in fresh water and drinking water. What I'm trying to say is that some of the pesticides are at the safe levels, but depending on how they will be, the more information comes up, maybe the values will be lower, and then the water that was considered potable is not going to be considered anymore. This is one thing that we need to start thinking, because this is changing all the time. So it's hard to continue with the old paradigm. We need more data to identify the priority ones, and then we need an effort to calculate the water quality criteria for the different uses of water, and then we can interpret the data that we have, and then maybe think about regulating them. I think this is an important process. Okay, then endocrine disruptors. Very brief. This was a project we did. In the past, 2000 to 2012. We analyzed several endocrine disruptors compounds and other compounds, and also we include caffeine, and this is very important for the rest of my presentation. We also included a bioassay. Some bioassays are very, very sensitive, and this one, it's a little bit in a specific, but you can detect endocrine disruptors such as EE2 or E2. It's yeast that has inside the estrogen receptor, human estrogen receptor inside. So this is a bioassay that is easy to do, and now the Environmental Protection Agency in São Paulo, they are monitoring the water with this bioassay. So why I'm saying I like that, because this in blue, those are the sites we analyzed. Some are bad, the bad rivers, others are better. But what I want to show is that if we calculate, based on the measurements of the chemicals, we calculate how much of endocrine disruptor activity we would expect, you are going to see this in blue, right? But then when we used the bioassay, we saw much more. So clearly there is a lot of other compounds or synergistic effects that are causing this. So the person that developed the assay, we had the visitor in Brazil, and she was amazed. She said, I never thought we would see in a river the amounts that we see in general for effluents. Okay. And then why I'm saying caffeine could be something that could help us. Caffeine. Caffeine is known to be an indicator of sewage in the water. Instead of coliforms, they are alive, they can die. Caffeine is there all the time. So I think it's something we could include in our monitoring thinking. Caffeine, and caffeine is being monitored in several rivers around the world. And what amazes us in Brazil is that the amounts that we are finding in some of our rivers, it's really a lot. It's 40 micrograms per liter in the water. Usually, I heard that in Europe, they have around 0.2 micrograms per liter. So this is very easy to discriminate and see the status of your water using caffeine. Okay. Then we tried to do some correlations and PCA analysis, and we found that caffeine was at some point correlating with estrogenic activity. So we published that paper showing that maybe caffeine could be used as an indicator. It's not a direct indicator, but this could help us try to track what are the hotspots that we need to work a little bit more, right? Okay, and caffeine analysis is cheaper than the others. We still need some equipment, but it's different from the ones that we need for the EE2 and so far. It's much more expensive and more difficult. But you can even do in GCMS, which is really, it's more common. And we calculated also, it's very simple to analyze, and the cost is not so high, okay? If you were not very strict about how much you want how much you want for limit of detection. So we are seriously thinking of including caffeine in our monitoring programs. We have lots of data now, and I'm going to show in the future, I hope, to you in publications. Okay, so conclusions: the majority of the surface water samples presented endocrine disruptors and other emergent contaminants. Human sewage is the main source of contamination. Conventional treatment is not able to remove emergent contaminants. Bioassays such as BLEES and others can be important analysis to complement chemical analysis. And caffeine can be useful to trace sewage contaminations in surface water. So, this is just a small story. When we started to publish that data, okay, I will be very fast. The companies became, the sanitation companies became very, very mad at us. They didn't want to discuss that. And I can understand that because there is a reason, sorry. There are so many issues that we need to deal in Brazil. Imagine this happened just in June 2015. Right? So we have that situation in Brazil. No water, lots of microcystins. And on the top of that, they need to worry about this other emergent contaminants. But this is going on. There is this report. There's even a regulatory proposal for EE2, that the amount is really minimal. We also showed some endocrine disruptor in vivo in rats in our drinking water. So then the company said, well, emergent contaminants will be included in our agenda. And this is how now we are doing a lot of partnerships with the universities and to develop treatment technologies and also to develop and also to monitor. So I think this is, sorry. So I think this is the big challenge. We need to solve the old problems and the new ones at the same time. And I understand the problem with Africa and all the countries. But this is it. We cannot just, don't see it. And we need to jump ahead, and implement the best available technology. Monitoring data is needed. We need to include chemical indicators of low cost, maybe caffeine, and some bioassays could be used. So I think a worldwide effort of academia, government and non-government organizations is needed to develop affordable treatment and monitoring technologies to all nations to protect one of the most valuable resources in the world, that is the water. Okay? So thank you very much.
So now we can accept just only one question.
Okay.
Anyone? Yes. Sorry. Oh yeah.
Thank you very much. Very interesting lecture. My question is the problem of pesticides due to the increase of the quantity per hectare per year, or the variety of pesticide, and is it related to the biofuel? Because you said it's increasing. Is it related to the biofuel agriculture now?
Yeah. Exactly. In São Paulo, we are 40% of the alcohol production in Brazil, which is sustainable energy, is produced there. And that's why we have so many herbicides. Atrazine, simazines, all those compounds come from that. So it's really related to the agriculture for sure. And it's increasing.
So,
Thank you very much.
thank you very much.